Alright, so we are going to attempt to do this lesson over video, even though this is a lesson that would have been very helpful to do in our teams in the classroom, but it's called 8.3.3, How Can I Build It? And it's about constructing shapes. So it says architects and drafters make careful drawings of the buildings that they design. The drawings represent how the building should be constructed. They show the thickness of the walls and where doors, windows, and pipes will be. To make these precise diagrams, professionals often use special computer software. However, some architects still prefer to draw diagrams by hand at least some of the time. They use special drawing tools that look something like those in the drawing at the right, including a right triangle tool and a protractor. Building plans are just one example of a precise geometric drawing. Mathematicians have used these basic tools to draw accurate diagrams for other reasons. In mathematics, making a construction is the process of using a straight edge and compass to solve a problem or create a geometric diagram. Constructing shapes that meet different guidelines can help you understand many of the specific characteristics of those shapes. In this lesson, you will use given conditions to construct your own shapes. So for 8-80, it says, without looking at anyone else's work, each member of your team should draw a triangle with one angle that measures 60 degrees and one side that is 1.5 centimeters long. So I know that a lot of us don't have access to a printer, so the resource page that I have is right here, and I actually had it up on my screen earlier, but here's the resource page that this lesson comes with, in case you don't have a ruler or a protractor to measure out angles and measurements and stuff. So it said to make a triangle with a length of 1.5 centimeters. So what I did is I just traced, so say I was on my computer, hold on a second, let me get the resource page back up. So say I was on my computer, and let's grab, oh gosh, that's not a good example, is it? Let me get a blank piece of paper. There we go. So if I wanted to trace a triangle with the length, one side has to be 1.5 centimeters. So I would have traced as best as I could. I'm trying to do this with one hand, but I would trace that 1.5 centimeters, and I'll try to do it right now. I'll try my best. Let's see. Not bad, not bad. Okay, so there's my triangle's side. Pretty small. Now it says it wants us to have our triangle have one angle, sorry, I'm trying to focus, one angle that measures 60 degrees. So here's what I did is I lined up my 1.5 centimeter line with one of the dashed lines for 60 degrees. Let me see, I gotta do it without looking at there we go. And then I drew a line. Oh gosh, I don't know if I can do this with one hand. Oh, maybe, I'll try to do it with one hand. Let's see, I can do it. There we go. So there is my 60-degree angle. So you should have something like that on your paper. And then what I did is I just connected the two lines together like that. It's kind of a icky triangle, but just ignore that little thing I did. Okay, so that's the 60-degree. And then it wants us to figure out what the rest of the angles would be. So if you don't have a protractor at home, you can just follow along with my little triangle. And I'll show you the one that I did last week. So I did this one last week. It's a very poorly drawn triangle because obviously that 90 degrees does not look very 90 degree like right there. But it does, I tried. That was supposed to be a much straighter line going from here to here. So if we had a 60-degree angle here, a 90-degree angle here, and I measured that with my protractor and it was about 30 degrees. So if we added them all up, we would get 180. 30 plus 60 plus 90 is 180. So if we had been doing this in class and we had a bunch of other triangles to compare with our team members, we would notice that all of our triangles' angles would add up to 180. So that is going to be the whole takeaway from this problem. So for part B, it says to write I think it says to write a conjecture. Let me see. It says, what is the sum of the three angles? The sum of the angles is 180. Make a conjecture about the sum of the angles in a triangle. So you can say the sum of the angles in a triangle is 180 degrees. So that is the first problem, 8-80. So then 8-81, it says, again, without looking at each other's papers, have each member of your team draw a quadrilateral with one angle that measures 30 degrees, one angle that measures 60 degrees, and one side that is 5 centimeters long. I'll show you the one that I came up with, but remember, quadrilateral has 4 sides. So I'm going to show you, first I'm going to show you my not very good one. So I did, let's see, this is the one I did last week, and I wasn't very proud of it. And when I added up all the angles, I got 265, which really didn't seem right to me. So then I went here and I drew this like trapezoid guy with the 5 centimeter length of that bottom line. I drew a 60 degree angle there, a 30 degree angle there, and then I measured those 2 angles with my protractor. And adding them all up, I got 355, which was closer to what I was trying to aim for, because our whole gist of this problem is that our sum of the angles of a quadrilateral is 360 degrees. So part B is going to be the same thing as the last problem, where you have to make a conjecture about the sum of the angles in a quadrilateral. So the sum of the angles in a quadrilateral is 360 degrees. So obviously it's not perfect, but if we were in class, we would come to that conclusion, and it would work a lot better if we had a lot more triangles than quadrilaterals to work with. But, you know, we do what we can with what we have with our distance learning. All right, moving on to 882 is the last problem. So it says all measurements have a small degree of error, and measurements made by people can vary quite a bit, as you discovered in lesson 811 and 812, which we didn't do, but that's okay. Okay, so using technology to construct shapes can give you more accurate information and allow you to test more situations more quickly. So now we're going to check our conclusions from problem 880 using technology, work with a partner to make a triangle with the same conditions as those given in problem 880, and we're going to use the E tool this time. So I think I already have it up. Nope, I have that up. So let's get the E tool up. So we want to make a triangle here with a length that is, it has to have 1.5 centimeters for one of its lengths, and then a 60 degree angle. So let's make this one 1.5 because it's close already. There we go. And then you'll notice the angle measures are over here. So angle A is that, angle B is that, and angle C is that. They're not 60 yet, so we need to make one of those 60 degrees. So let's see if I start moving this around. Let's look at angle A, because angle A looks pretty close to 60. So if I keep moving it down, angle A keeps getting bigger. There. Right there. So that's my triangle with a 1.5 centimeter length and 160 degree angle. Oops, it's right there. There's A, 60 degrees. So let's look at what the sum is. Well, it's still 180. So 76.7, 43.4, and 60. If you add them all together, you get 180. Those are the angle measures on the inside. So it looks like it's holding true our conjecture from 880. And it says to like keep testing triangles with your teammates, but we just don't have access to that. So if you wanted to play around with this and try to make more triangles with 1.5 centimeter side and a 60 degree angle and see if it looks different, you can, but the whole gist of this is that, see, look, I just made a triangle that looks different from that last one. Right there, I'm just gonna leave it there. So C is about 60 degrees, but we do have a 1.5 centimeter length right here, but still all the angles add up to 180. So we're proving that the triangle's angles, the sum are 180. So that's that first part of 882, part A. So the sum of the angles for each triangle is still the same, yes. All right, so now it says using the same technology, we're gonna figure out the quadrilateral problem. And it wanted us to have an let's start with the side length of 5 centimeters. So let's make this side 5 centimeters there. And it wants one angle that measures 60 and one that measures 30. So let's see, how did I do this? I think I went out like this, because if you go out like that, it gets smaller. Let's see. That one, so angle E is almost at 60. Whoa, this one's looking weird. I'm gonna do this. Angle E is now about 60. There. Angle E is 60. Let's see. And that one's still 5 centimeters. Let's try to make this one smaller. 30. I'm looking for 30. We're looking for 30. Oh, right there. Almost. It's 31. So here's our quadrilateral. Still has a side of 5 centimeters. Angle E is 60. Angle F is 60.2. Angle J is 31. And then angle H is 151.2. It's a big, obtuse angle. So they all measure up to be 302. What? I must have messed up there somewhere. So it should be measuring up to 360. Oh look, you know what? You can't have it concave like that. Because if you concave like that, then it's not 360 anymore. So it has to be, oh, and you know what? If you do that, you have 1, 2, 3, 4. Yeah, that doesn't work. So if you mess around with it and try to get a 30-degree and a 60-degree angle, you'll notice that there's different ways you could do it, and it all has to equal 360. All those angles for a quadrilateral have to be 360 degrees. All right, I know that was kind of difficult to do. It would have been nicer to do in class, but you know what? We just gotta make do, and you can play around with these and try to make some weird shapes, but still all the angles have to be 360. All right, so I will see you in the next video.